Okay. Get started with our next speaker, next presentation. Pleased to introduce Alessandro from GraphAware to talk about building knowledge graphs within Neo4j.
Okay, cool. Thanks, David. Good afternoon. As David said, I'm Alessandro Negro, and I'm the GraphAware Chief Scientist. Today, in this presentation, I'm going to be talking about how to convert the information available in multiple and distributed data silos in knowledge graph. More in detail, I'll walk you through the several challenges that you have to deal with and the different solutions that you can adopt along the path of converting this data into actionable knowledge. Let me give you a disclaimer of a note about this talk, because I know that it has been scheduled after lunch, so I added more image and animations in order to make it more interesting for you and avoid, as much as I can, you to fall asleep. So we will focus on a very specific task, that is converting the data that you already have in actionable knowledge. So we will not talk about a general kind of knowledge, but a very specific type of knowledge that you can convert into actions that could be improve the quality of your products or saving costs for your companies. And this requires a mental shift from the classical, let's say, warehouse mentality based on KPI to a more to a different approach based on thinking, based on prediction. And let's say that this is necessary because we already a lot of companies, maybe all of them, that are already storing different kind of data in multiple and distributed data silos, and also in different kind of data sources. Because we are not talking about only the data available in well-structured data silos that are designed, might be on top of a relational database for the specific needs of an organizational unit. But we are talking about any kind of data that could be emails, that could be chat, that could be product documentations that are available for any company right now. And we will try to address some kind of actions that reply to different kind of questions in your company. Like, for instance, do you know what your customers are going to need in the next 12 months? And do you know how are you going to provide it? Or are you making the best use of information that you already have in order to make a better solutions or to deliver a better product in the next iterations? So these are the kind of actions of the question that requires some kind of action in order to be satisfied. And as I said, this requires a mental shift, that it is quite complex. So I tried to collect and organize the mental path that brings a CEO, a CTO, or an architect to think about the data available in their own company in a different way in order to convert them in actionable knowledge that could be, as I said, improving customer experience through delivering a better service or delivering a better product, that could be saving costs for the company, or taking better decision in the next iteration, or just avoid to make the same mistakes again and again. And we will see along this path how you can occur in some kind of issues or some kind of error, and how to overcome all of them. And we will see what will be the best solution that you can adopt in that sense. So supposing that you are the CEO of a big company, and you would like to organize all the data available in your company. I'm thinking about emails, chat, product documentation, wiki pages, blog posts, and so on and so forth. In order to gather all this knowledge that is so distributed and collect them in a trusted single source of truth that allow the CEO to really represent the current knowledge of the company. Or supposing that you are the CTO of an healthcare company that would like to deliver a new set of services to their patient. So in this case, again, what he can do is to gather data from multiple contact points, like ambulatories, like pharmacies, like hospitals, like call centers, and organize them in a connected source of truth, on top of which build the next generation of the services that they would like to deliver. Supposing that you are running a manufacturing company that would like to deliver better products to their customer, or just reduce the costs for maintenance. In this case, what you can do is to gather data from product documentation, from customers' complaint, from supply chain notes or distribution chain notes, and learn from past experience for delivering better products in the next iteration. Finally, supposing that you are the architect of a travel website, and again, you would like to offer a new kind of service, not only to the end user, but also to the hotels. In this case, what you can do is to gather the information available in hotel's description, in the customer's complaint or the customer reviews, in some open data like tourist information, and organize them in a way in which you can deliver better recommendation, because you can spot hotels' issues or hotels' strength quite easily, and then use them for delivering different kinds of service to the end user. In all these cases, what could happen is that this CEO or CTO will call the developers team and ask them to create a new platform or use an existing platform to gather all these data from which he would like to extract new knowledge. So what they will do is to start going over the entire set of data that they have. And as I said, they could be different kind of data. So they could be relational database, they could be textual document, and so on and so forth. And try to find a solution for collecting in a single source of truth this data. The first approach could be a relational database, even though this is not quite common anymore. But suddenly they notice that, let's say, this is not the best solution for two main reasons. The first one is that the data are so heterogeneous that cannot fit easily in a relational schema. And the second reason is that these data are quite a lot. So organize them in this relational database could be costly in terms of maintenance, in terms of creating the right index or create the backups, and so on and so forth. So they immediately discard these solutions and go over another solution that is based on a search engine, for instance. Let's say that the search engine could appear quite a better solution, because in this case, you can solve both of the problems that you had before. In terms of structure, there is no issue, because you can have multiple indexes and organize the document in a way in which you want. And even in terms of, let's say, data dimension is not a big issue, because you can, with all the tools available, like Elasticsearch, for instance, you can scale quite a lot across a cluster of machines. So they are happy about this solution. They start gathering the data, collecting them into some indexes, fine-tuning the query, and deliver this solution to their CEO or CTO. He or she starts looking at the solution, and that it appears quite interesting, because he can search for the knowledge. But after a while, the limitations of these solutions appears, because let's say these kind of solution allow just to go over the set of documents that you have, quite in a good way, to be honest, because search engines work quite well. But there is no way for extracting real knowledge, because the documents are not connected. They are just isolated. You can get a list of documents, and that's all. And even just making a kind of a conceptual search is a pain. So he's not happy. So again, the developers team has to work overnight, try to implement some kind of aggregator mechanism that allow to merge multiple documents coming from multiple data sources in a single document, because this is the only way that I have. And also try to implement some kind of semantic search, ingesting synonyms, and so on and so forth. But again, this is not the right solution, because it cannot scale in terms of simplicity, because as soon as a new data source has to be integrated, the effort for integrating it is enormous. And just changing a single synonym could be a big pain. So at the end, all these solutions are wrong, because they cannot reach the goal that was the original goal of the CEO or the CTO. So the CEO is not at all happy, because they can miss the deal, they can continuously spend more money for this new platform, and so on and so forth. There are some reasons that we can just summarize why this is not the right solution. First of all, the kind of platform that we need is a platform that has to handle the big data. Because as you can imagine, we are talking about different and spread data sources where the good part of them could store a lot of data. And moreover, we cannot trust all these data sources, because I will never trust a chat between colleagues in my company. Or again, even the speed at which these are generated is quite a lot. So it exposes the 4 V's of a big data platform that are, as you know, volume, velocity, variety, and veracity. But, and this is why we discarded, since the beginning, the solution based on the relational database, because a big data platform cannot fit in a relational database. Furthermore, the problem is also that organizational leadership want a solution for data to be integrated at speed. That means not only that this new solution has to be integrated in the existing platform, but also that as soon as a new data source has to be integrated, this should be quite straightforward. And the solution before, as we saw, is not that case. And furthermore, it should enable knowledge workers to be more efficient, effective, and consistent. But there is a big question that remains unresolved. That is, where is the knowledge? In a kind of search engine, there is no knowledge. It's just a way for indexing what you already have. It's fast to search, this is true, but there is nothing more than the same documents that you have at the beginning. And I will show you why. Supposing that you would like to implement a search engine, it will be like this. So you will have a textual search form with some kind of filters like dates, like topics. Once you press on search, what we will get is a set of documents like this. And this is not that simple, to be honest. Because at the end, you can represent the search engine in this simple way, where you have a kind of black box where you put documents from your several data sources, and then the users can perform queries and get back some responses. So the most interesting part in this platform is the indexing part. That is based on, let's say, on a quite old concept, that is the inverted index. I'm saying quite an old concept because I think that the first book printed by Gutenberg already has this kind of index structure. That is what you find at the end of any book, where you can search for the words, and for each word you can get the list of pages in which this word appear, or at least is used in an important way. So in a more formal way, we can say that we can create an inverted index in this way. Starting from these 3 different sentences, we go over a process of analysis in which for each sentence we extract the list of tags. We remove the stop words that are the most common word used in the language. And then once we have the list of all the words, all the distinct words, we can create a vocabulary like this, where we assign to each word an index, like an integer or a long value, just to avoid to use the entire word more and more. And then using this, you can create your inverted index. So for instance, if we consider the word best, you have that in the second sentence, there is here and here in the third. So 0 is pointed to 1 and 2. The word blue appear here on the first sentence and on the second sentence, so you get this. So maybe that there is a question in your head right now, that is, where is the knowledge? In this indexed structure, there is no knowledge. It's just a way for organizing the documents in a way in which you can easily access to them through a textual search engine. It's, to be fair with, let's say, with the search engines, you can do a little bit more, obviously. You can put in the middle between the extraction and the inverted index some kind of enrichment. As we discussed before, the developers team worked overnight to create these kind of aggregators that gather data from multiple data sources, can add different kind of contexts, information, can extract even sentiment. But at the end, they end up in the, let's say, in an inverted index. So this solution is quite easy to implement, even to maintain and to deploy, because it is based on a well-established tool like Elasticsearch, for instance, that allow also you to spread the load across a huge set of machines if you want. So at the end, what you can deliver is a very fast search engine. But this is not enough, because at the end, just tuning results is a very hard task. And at the end, you cannot, what we get is that every single document is isolated. There is no way for navigating from one document to the other one. And even just extending what you did at the first site is very complicated, because just adding a new synonym in a list means that you have to go over a reindex process. Forgetting what? Just a textual search. And again, even with these extensions, at the end, a question could rise again. Where is the knowledge? You can add a small amount of knowledge, but this is not enough. So let's see what you can do with a complete different approach. Let's see with a graph approach. Supposing that you have a text like this. This is a document. It is an article that I took from the New York Times some time ago. So let's go over another kind of process in this case. We would like to process this article using a natural language processing tool. So in this case, what we can get back is something different than before, because if we train the natural language processing tool, we can recognize in the text that HomePod is a device, and the same is for Echo. You can recognize companies. And look, this is not a simple task, because, for instance, if you consider the Apple example, Apple is a fruit, but it is also a company. So when we are talking about extracting knowledge from the text, it means also that we need to apply some kind of word disambiguation to extract from the context if we are talking about Apple like a fruit or Apple like a company. Furthermore, we can access to other sources of knowledge and extract information like this, so that this device, the HomePod, is produced by Apple. So we are talking about a different kind of approach to the textual processing, because instead of having just a list of tags, here we are relating some concepts to the words. So we know that HomePod is a device, that Apple is a company, that there are connections between these devices and these companies, and we can continue. We can infer the list of peoples that are, that are in some way involved into these articles. And again, using Wikidata, for instance, we can find that Elon Musk is the founder of Tesla and the founder of SmartX. We can do further. We can recognize money. We can recognize part of the text, like it, that points to HomePod. We can recognize Siri, that, again, using ConceptNet 5, allow us to know that it is a software. We can extract the time. We can extract the dates. We can even, again, extract sentiments. And we can, for instance, in this case, extract the sentiment for this sentence, and through this path, knowing that we are talking about the HomePod, we can relate some metadata to this document. So we can add information about when we read it, where we were, and on which device. So already from here, you can notice that instead of using a classical Bayes analytic approach, we can go over this natural language processing approach, in which we can extract a lot of information from the text. But the problem at this point appears because we need a platform, let's say a storage model, that allow us to store this information in the right way so that we can access to them. And we cannot use let's say, an inverted index. So what we can do is to use a graph. And as you can see, it is the right way because we can assign labels to the elements, and it's quite easy to represent them in the form of a graph. Obviously, this is a simplified version. You can do quite more. But again, this is not enough because what you can do is that if you go over the same process for all the documents that you have, what you can have back is something like this. You are creating a knowledge graph. You are really creating a data structure that allows you to extract more insight from your text. Because, for instance, two documents that could appear like unrelated, because one is talking about Elon Musk and the other one is talking about Tesla or a very specific model of Tesla, they could appear as isolated, and they will in Elasticsearch, for instance. But here, using the complex natural language processing tool, you can store them in the form of a graph. You can find that here we are talking about Elon Musk. Elon Musk is the founder of Tesla. That is one of the topics in this article. So these two articles are connected in some way. So what you get back is a kind of graph that allows you really to store and manage the knowledge that you have from the set of documents that you have. Because currently, with this approach, the documents are not considered isolated anymore. They are connected in a way or the other. And this gives you the multiple, flexible, and unpredictable access patterns. Because in a graph, every single node, every single relationship is an access point. And once you go over this access point, you can navigate a part of the graph or the entire graph following relationships and following the different nodes. So at the end, what you get is a knowledge graph that can enable different kind of artificial intelligence tools, so you can apply different kind of machine learning algorithms and enrich the knowledge that you have, because you can extract more insight from the knowledge graph that you build just analyzing the text. Obviously, there are some drawbacks, let's say. The first one is related to the fact that you cannot get the same performance in terms of textual search, but we will see later, we can integrate this approach with Elasticsearch, for instance, and get the best from both. You cannot shard. This is true, but to be honest, there is no reason to shard the graph. You would like to access as fast as possible to this graph, but you can replicate it. So you can anyway deliver some kind of performance improvement, replicating the same graph across a cluster of servers. Furthermore, it is very difficult to implement. And we will see how we will solve this issue. But before that, let's focus a little bit on the role of the knowledge graph in this goal of gathering data and create and extract knowledge. Let's say that the knowledge graph is the only way to manage the whole of enterprise data in a full generality. First of all, because knowledge graph is able to describe real-world entities and their interrelationship in the form of a graph, obviously. We can relate any kind of classes to these entities, to this relationship. As we saw before, we can have a device, we can have companies, we can have people, and for the entities. And we can assign different kind of relationship, like the founder, product by, is related to, and so on and so forth. And the knowledge graph by itself is completely topic agnostic or domain agnostic. So you can use it for any kind of scope that you have. And currently, all the big companies like Google, NASA, eBay, Facebook, Yahoo, and Microsoft are already using a knowledge graph for delivering different kind of services like semantic search, like I don't know, smart services to their user, or just to deliver data to their user. So currently, the use of a knowledge graph is not anymore the exception. It is the rule. It is the norm. And supposing that now I convinced you, did I? What should you do to get started? As I told at some point, This is not that simple because it requires a lot of tools. It requires a lot of skills related to natural language processing, related to managing graph in the right way, so defining the right model. This is why we came out with, let's say, the GraphAware knowledge platform that is specifically designed to convert unstructured data silos in knowledge graph. So we created a kind of knowledge architecture where we have multiple data sources that could be data silos as well as any kind of data sources, as I told you before. And then you can organize them in the form of a knowledge graph that is stored on Neo4j. And then on them you can apply different machine learning tools, even a recommendation, for instance, and deliver different kind of user experience, different kind of user access to this platform. So for instance, if you come to our booth, you can see how we integrated it with Amazon Alexa. So to deliver some kind of chatbot mechanism that allow you to navigate or query your knowledge graph using your voice. We also create a sort of assisted search that is based on a mix between textual search and graph navigation. Or you can just use the knowledge API that we built on top of the knowledge graph to deliver any kind of service to your end user. So this kind of platform, as I said before, has been explicitly designed to managing textual data. But obviously, once you manage the data and you store them in the form of a graph, you can enrich it in the way in which you want. You can add new information. You can even apply any kind of machine learning tool on top of it. So what the platform offers is some way for importing your data, wherever they are, enrich them, and then provide a set of analytics tools that allow you to easily, and mostly in an unsupervised way, extract knowledge, extract information from the set of data that you have. So let's say how it works in a very simple way. So supposing that you have a lot of data sources, they are converted in a form of a graph, as we saw at the beginning, using the natural language processing tools. So we have tokenization, named entity recognition, and we can, for instance, train our name and entity recognition to identify things that otherwise cannot be recognized. The tokens are normalized, and so on and so forth. So once you have this first graph, you can go through a process of enrichment in which you can use external source of knowledge. That could be ConceptNet 5, that could be IBM Watson for image recognition, for instance. That could be Microsoft Concept, could be your specific domain knowledge. And so you see that you have a bigger graph. Then again, you can apply on top of these other machine learning tools, like keyword extraction, like LDA or LSA, that are mechanisms that allow you to clusterize your data set or using different kind of approaches and assign to each cluster a set of words, for instance, that allow you to identify the cluster. You can apply similarities. You can compute the word to vec, and so on and so forth. So at the end of the process, you have a very huge graph, well organized, with a lot of indexes based on the keywords, based on the clustering, based on whichever algorithm you have that can be navigated using similarities, for instance. And you can use this kind of knowledge in multiple ways, because you can extract a simple bag of words that could be the input for another set of machine learning algorithms that are following in the pipe, or you can export multiple views and store them in Elasticsearch and deliver a relevant search to your user. Or you can just provide a different kind of visualization on top of this knowledge data set for communicating the data, or just for allowing your customers to access to the same set of data in a different and complete new way. And in this scenario, let me say that Neo4j is playing a very important role, a key role, because it stores the entire knowledge graph that represents the single trusted source of truth on which we are building our platform. And in this way, it delivers us multiple, let's say, services like fast access patterns through the Cipher query, for instance. And this allows us to easy merging data from multiple data sources or enrich the data with external sources. And since at some point we have to go live, it offers us also scalability capability in terms of replication that allows us to scale the, let's say, the access through an entire cluster of machines. So at the end, we created this kind of architecture in which we can have multiple Neo4j where we install our plugins. The great part of them are open source. There is only the NLP Enterprise that is not open source yet, that allow you to, let's say, enjoy the cluster because allow to spread the load of the computation across the entire clusters. And we offer a lot of tools for integrating this infrastructure with external tools. I already talked about Elasticsearch, for instance, for indexing and searching, but also we provide interfaces for Spark, for TensorFlow, and we are designing a platform that allows you to integrate multiple kind of distributed platform in the case in which you would like to use your own architecture. I'm thinking about, I don't know, Amazon Lambda or whatever else. So in order to wrap up some conclusion, we saw how converting data in distributed and multiple and distributed data silos or data sources in actionable knowledge is a very complex task. If you would like to have a solution not like a search engine but based on the knowledge graph. But we saw what are the advantages of having this kind of approach. And at the end, the knowledge graph represent the best approach, maybe the only really useful approach for addressing this kind of issues. And in this direction, the GraphAware knowledge platform allow you to simplify this hard path of converting such distributed data sets in an actionable knowledge, because it allows you to extract, to avoid to take care of the details in terms of natural language processing, in terms of exporting data in Elasticsearch, for instance, or distributing the hard or the heavy process across a clusters of machine. And it just hide all these details, giving you the opportunity to focus on your business, to focus on what is the kind of knowledge that you would like to extract from the set of data that you have. That's all. Thanks.